not the physics. Okay. So, last time we did the product rule and the quotient rule. I don't know if anybody has studied this stuff before, but somebody might actually know what the next rule is.
Chain rule.
Chain rule is next.
Wow.
You know the chain rule?
Yeah.
I don't know your English name.
Chain.
Explain it to me.
Chain.
I don't know. What is it? You can
Weirdo.
give me, exam?
Guys are so weird. Okay. Chain rule. Okay. Loud mouths. When do I use the chain rule? For what type of problem?
C,
Sorry, I'm just going to sip my coffee, pretend I didn't hear that, and ask again. Alright, so when do you use the chain rule? What type of problem?
A long problem.
Not necessarily.
Complicated.
Yeah, but how is it complicated? In what way? Huh? Not necessarily quadratic.
complex with cost.
No. No, in fact, it could be for even a very simple problem.
Like product rule connected.
Like product in that it's simple, but what have we not done? We've done product, we've done quotient, so what else could there be?
Plus and minus.
Plus and minus don't need a special rule. Yeah, no, connected how? Not quite like this. A chain rule is for problems where one function is inside of another function. For example, sine of log x. This is not a product, because a product would be this. Right? That's a product. And that is not a product. They're not the same.
Oh, yes.
Yeah. This is when we need the chain rule. When we have one function that's inside of another function. You understand?
Yeah.
When we need it. So the rule is actually pretty simple. Basically the rule is this, but I need to explain how to use the rule. So the rule is dy dx equals dy du du dx. Yes? This is the chain rule. And the proof is quite simple. To prove it, I just do this. And it's proven.
Yeah.
The du's cancel, and I'm left with dy dx. Now, yes, well this is why I said I'll need an example to explain what the u is doing.
Like sine to x.
Yeah, for a problem like this, yeah. Okay?
Okay.
Scroll down.
Yeah.
Yeah? Now, let's take an example. In fact, let's look at the example I gave you. Sine of log of x. So the way the chain rule works is you start off by saying let u equal.
Log x.
Yeah. You let u equal log x. Basically, you let u equal to what's on the inside. Yeah?
Yeah.
So if you do that, instead you now get
Sine u.
yeah, y equals sine u. Yeah? Let's just replace it, replacing log x with u. But now the problem is simpler. You can now work out dy du is, yes, cos u.
Cos u, yeah.
By the way, you can also work out from this what du dx is. What is that? 1 over x. Now if you use this rule at the top, dy dx is dy du, which I know, multiplied by du dx, which I know, can I get my answer? If dy dx is equal to dy du times du dx, then it will equal cos u times 1 over x. which will equal cos u over x. Now I'm nearly finished. There's one thing left to do. What is the problem with my answer? Looks like, yeah, I should only have x, yeah, and I can do that by remembering that the u is log x. And that is the derivative of sine log x. It's cos log x over x. Okay, we'll do much more now. More examples. I need you to write this one down.
Teacher,
Mm-hmm.
that means the inside will multiply outside.
Say again, the what?
The inside will multiply outside. I mean there.
It's not really multiplied, but the inside is the u.
Yeah.
Oh, you mean this rule?
Yeah.
Yeah. It is the derivative of the outside multiply derivative of the inside, yeah. Okay, you got that? Not yet. Not yet. Got it. Yeah?
Yeah.
Okay. Continuing. So, there's a few examples I want to do. And in fact, there is another way to do it. And what happens is, I show students this way, and then I tell them there's another way to do it, and I show them the other way, and they said, oh, that's easier, you should have shown it this way. And then the next year, I would show them the other way first, and I said, oh yeah, there was another way to do it. And I said, the other way's easier. I'm like, you guys, you're crazy. So I'm just going to show you both ways, and you decide which way is easier.
That way is easier.
Well, you haven't seen both ways yet. So just before I show you the other way to do this, I want to give you one like this to practice. So we'll keep it simple for you. We'll say something like y equals e power sine x. Now I want you to do it using this method. Okay, so I'll give you a minute. Try that. This is Connell texting me to say he already told you there's no assessment support.
Yeah.
Yes. Okay.
Thank you.
How are we doing? Sean, you have an answer, do you?
Answer?
No, don't tell me. I just want to know, do you have an answer?
Yeah.
Okay, good. Easy?
Maybe.
Maybe.
What? No. But it doesn't
I'm trying to think what Marvel superhero he is. If you're Captain America,
Captain America.
I don't know.
Captain America.
Kind of got a Spider-Man vibe about him. Would you say?
Arrow.
No?
No. Spider-Man is genius.
Yeah.
No, Superman.
That's what I'm saying.
Superman.
But
Iron Man.
Yeah, Superman or
Wonder Girl.
Superman. Yes, talking about Marvel for me.
Oh, okay.
Okay, you got an answer? Yeah. What did you get, Bruce? Oh, you're not finished?
What is you?
What is you?
Oh,
Bruce. Bruce. It's you.
Dying.
Wow.
Yeah.
Yeah, from
Okay,
to the
so
power.
what we do, hey dudes, come on. Jerry, please. Jerry, just look, please, thank you. Let U equal sine x. I hope you all said that.
Yeah.
So you get y equals EU. Oh, and over here, what does du dx equal?
Cosine.
Cos x. And what does dy dx equal?
EU.
EU. So then dy dx equals EU cos x, which is E sin x cos x. Yeah?
Don't we have to put cos x?
No, it doesn't matter. You don't have to.
I
You don't have
think,
to.
yeah.
Yeah, this is fine.
Theoretically.
Yeah. No, this is fine. That's fine. Now, let me show you the other way to do it. I reckon, yeah?
Is that same as the thing we learned, the positive and negative? I don't know what that's
Chimney.
called. Yeah.
I don't think so.
What's this?
No,
But
it's
why smoke? What means the clean one, right?
which chimneys are coming out?
It's a fire.
Well, it depends what they're burning.
Oh.
Because in Ireland, it's the law that the material you burn has to have a minimum. Like it can't be like dirty black smoke that like sticks on things. It has to be what's called smokeless. Now, of course, it's not smokeless because there's smoke coming out. But what they mean by smokeless is it's not black. That's why it looks like that, because it would have been treated to not burn black tar, in the atmosphere.
Smoke must be.
Oh, it's smoke. Yeah, it's smoke. Yeah.
It's wood.
No.
I always think it's clean.
I don't have.
No, it's smoke. It's just clean smoke. It's not like Chinese smoke.
Oh,
Chinese smoke is delicious.
You win.
I used to
You smell it every day.
Ah, you're used to Chinese smoke. This makes a lot of sense. Ah.
I lived there for 16 years. I'm actually.
That was 28.
Interesting, because I heard the smoke has effects.
Yeah.
My hometown is over my small.
Your hometown is built on the smoke.
No, I mean, my hometown is like 500.
Yeah.
But my hometown is over 500.
Over 500 what? People?
PM.
Pollution.
PM.
Oh, the pollution measure. Oh, yeah, okay.
But we still alive. This is our.
PM.
Yeah, we know why now.
500 is
because of you guys.
Okay.
My hometown is very clean.
Ah, Jerry, you have our sympathies. You have our sympathies. Yeah. Okay. Now, let's have a look at the other way to do this. So, the other method I would prefer you to use for the exam, because this method I'm about to show you is a lot quicker. Okay? And in fact, maybe it's even the way you might have seen it in school. So, let's take an example we have with the sine, let's just say sine of log x. For example. Huh? Yeah, so let's see if we get the same answer. Yeah.
Okay.
So what you do to begin, in your mind, you have to first see which part is called the outside and which part is called the inside. And then what you do first is you differentiate the outside. So the outside is sine. So what is the derivative of a sine x? It's a cos x. So this becomes cos log x instead of cos x. And then you multiply your answer by the inside's derivative. So what's the derivative of log x?
X.
1 over x. And then that's it.
The same.
I mean,
Of course it's the same, because it's the same question.
But this
I know
it's the same concept.
Yes, I know it is. I know it is. I'm just telling you, in the past, I would show students this way, and they would say, the other way is easy. And then first I showed them the other way, and they say this way is easier.
I mean, it's the same.
Yeah, the same thing.
The same way.
If it's the first
You
one,
understand
you're
how
like,
I feel?
why is
In the same way.
either way.
Yeah.
Oh, yeah, this is the easy way.
This is the easy way.
Yeah.
I agree. So we'll just do it this way. Okay? Now, let me give you a harder one now. Can I scroll down?
Yeah.
So try this one. Let's try E cos x sin x. Yeah. Good question. Good question. Which part do you think? Well, what rule
Product.
do you need, Bruce? What rules do you need?
Product.
Product and chain.
Yeah.
Yeah. And when you use the chain, Sean, when you use the chain, what's the inside and what's the outside? Yeah.
Inside. Cosine.
Outside?
E.
Yeah. Got an answer?
Almost.
Okay. Okay. Don't simplify.
Okay, I give up.
Why do you give up?
I tried to solve the front part and then combine them, but
Got an answer?
Relatively fun. It's like
Easy.
relatively fun.
You have an answer?
yes.
Yes? Okay. What rule do I need first, the product or the chain?
Product.
Product. Yeah. So, the answer is, the derivative is, first I differentiate e cos x, which is e cos x sin x, with a minus, thank you. And there's and then sin x. Yes, that's the first part, plus
E
cos
cosine.
x.
Cosine.
Cos x. Oh, this is easy.
Yes.
So this is e cos x, cos x minus
Sin x squared.
sine squared x, yeah. Yeah?
Yes.
Okay.
No.
What do you mean, no?
Where does that equals x come from?
The what?
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 You can like
Plus? Take out the e cos x.
Should we?
No, but for the next part I want you to.
We don't need to simplify.
Okay. Right, this is part A, okay? Now I'm going to give you a part B.
Okay.
Part B, I want you to find or to see, is there a turning point?
No. A point. Equal 0.
Yeah.
Teacher,
Yes.
how you find
How do I find what?
A?
A.
I don't get it.
The product rule.
Oh, what? Yes, sir. So you combine this thing with this thing. the product.
What?
Oh. Oh.
This is one of the strengths of a bank card.
This one would be no because no contract. This one I'm still
Good, yeah?
Yeah. But this is like
Yes.
How do we call that? That's how we, that's how I over
Derivative
derivative.
or dy dx.
Derivative.
Oh. Okay.
Did you spot it, KJ?
Yeah.
How is this side of the classroom now is being a bit sleepy today?
Sleepy.
Mathematically.
Well, so
We don't know.
We always be asleep.
True. But usually I can get good answers out of you.
How do we?
what is the question? Is there a turning point?
I believe, find the turning point
Yes.
and find it.
Yes.
So like this, cos square x
Zero,
plus cos
1.
minus 1.
Could be, I haven't calculated.
I mean, I just put zero in.
Yeah.
1 minus 1.
Why?
So we should
Like,
find
what's the one that's turning point?
Yeah.
Here's the second derivative.
If cos minus it should equal.
I'm starting
It's
to
as
Derivative of
it's as a radian of degree.
Radians.
Oh, it's radian. How do we
Yes.
know that?
Do we have the second
I told you this in semester 1, didn't I? It's always radians unless you see a degree.
Oh.
Do we have the how to find turning point? I forgot.
Equals 0.
Equal 0.
Okay guys, let's have a look here. Guys! We're having a look now.
Shut up.
Wow.
Whoa.
No,
he told me.
Yeah, no I know that. Because he looked at her. Yeah. Oh, they thought he said to me. Oh no! He said that to me. He'd be gone.
Get off! Oh, this way. This way. Open the window. Jump.
Yeah, he knows that. No, he knows that. No, he's a good boy. He's a good boy.
I put my hand up.
I know. You're a good boy. Good boy. Good boy. Okay. Let's have a look now. So, derivative equal to 0.
Yeah.
So who knew what to do first here? Yes, go on.
Bring over.
Open the bracket.
No.
No, cosine
Why not?
minor.
Bring over.
No.
No.
You open the bracket.
No.
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 E cos x equals 0.
Only cosine x minus sine x squared equals 0.
Yeah. This cannot be 0. So only this part could be 0.
Yes.
Same thing.
Not really.
Eventually you can.
Okay. Well, I'm doing it the right way. Okay. So what to do next?
Put the sine track
Sine
cosine substitute.
Yeah, I should change the sine squared into 1 minus cos squared.
Yes.
Complicated.
So this would be 2 cos squared x minus 1 equals 0, right?
No, because
No, did I got that wrong?
That is.
Oh, sorry, yeah, it's a quadratic. I know. I know. It doesn't look like this quadratic has roots, does it? It has a...
there is.
No, I'm sorry, what I mean to say, you can't factorize it. No, it has surd roots. So you get cos x equals minus b plus or minus square root of b squared minus 4ac all over 2a. So you get cos x equals minus 1 plus or minus root 5 over 2. Now, I think one of these answers won't work because you'll have, you'll have x equals cos inverse minus 1 plus or minus root 5 over 2. Now, really there's multiple answers here, but I would just want the smallest answer, okay, for practice. I feel like if I use the minus answer, it will not work because it'll be too big for the cos inverse.
Where's the formula?
Which formula?
The b squared.
This one.
Yeah.
This is a, b, and c.
Oh.
Yeah.
B square
So
minus
yeah.
is.
The x.
Oh.
Yeah. Guys, does this have answers though? Does both have answers, the plus and the minus?
No. The plus has the answer.
Yeah, but the minus, no answer. Yeah, so just taking the plus one, this is minus 1 plus root 5 over 2. What did you get?
0.905.
0.905 is it, yeah.
Teacher,
Yeah.
why we don't have to get hundred fraction?
Get what?
Like the eyes of it.
Well,
Because we have to get a turning.
yeah, I want the turning point, yeah. To get the turning point, I need to make this 0. Yeah?
Zero. Directly
Is 0 is turning for turning point. Yeah?
Teacher,
Yes.
why is it always radian?
I know, but the definition of cos, sine, and tan is in radians. Like the cos of x, the cos of x is defined. Cos is defined in radians. Like it's your question shouldn't be why do we use radians. The question should be why do we use degrees? Okay. The minus one. I don't think you have an answer if you use minus 1. I don't think so. KJ and or well, whoever. When you typed in the answer with the minus, it was an error. Yeah, no answer for the minus 1. Yeah. Now there actually is a second answer though. If we think about it, we remember from semester 1. The second answer for cos is let me think. It's no. For the second answer for cos, it's 2 pi minus the first answer. So the second answer here is 2 pi minus 0.905. Yeah. This answer is about 55 degrees. Yeah. What's this one here? 5 point. Are you giving me degrees or are you giving me this answer?
I got 51.
51 is this in degrees. Yeah. Okay. Do you mind just typing this in? 2 pi minus that answer?
251 can be.
They want radians.
5.38.
One of these will be a maximum and one of them will be a minimum. Yeah. I won't bother to find the y, but of course you know that you need to find the y as well because I asked for the turning point. Point means x and y. But if you picture the graph here, can you picture the graph of this? Let's try and picture this graph. What does sine look like? Sine looks like this, yeah? Roughly. And what does e look like? E looks like this. And what does cos x look like? Cos x looks like this. So what would e cos x look like? I'd say e cos x would kind of look something like this. If you put the cos x in the e. And then what would e cos x sin x look like? I think it'd be something kind of going
like this.
yeah. I have a feeling this graph will look something kind of like this. well, sorry, that's terrible. But it's going to shake. It looks like it's shaking, and it's going to go up, down, and get bigger and bigger and bigger. The reason it's getting bigger and bigger, no, but then it'll go back smaller again, actually, because the Cossacks repeats. Right, don't show me. I don't see. I want to try and draw it. Is it like this?
Wow.
Waffle. I just typed in E cosec.
Yeah, but E Cossack sin x.
E cosec sin E to the cosec sin x.
And sin x on the bottom.
Oh, wow, Andrew got prize.
Andrew got
Congratulations.
what prize? What prize?
What?
Congratulations.
And your didactic prize for you, engineering.
Really?
Yeah.
Who got a prize?
What?
Andrew.
Yeah, I'm so jealous.
Oh, Andrew from last
What
year.
prize?
That's the wizard. Oh, for last year, not
that's
me.
what?
Oh my god.
Huh? That's one.
No, there was an Andrew from last year.
Ah. The same Andrew.
Andrew, yeah.
I don't know your last
Did you draw it?
E to the cos
Yeah, e to the Cossacks.
cosec.
No, Andrew.
Yeah, e to the power of Cossacks. Like this.
Yeah, this is.
And put a sin x in front of it though.
here.
In front of the e,
That
yeah.
was outlet.
That's a nice screen.
Oh, that's
Sin
X.
So the name is
Oh, yeah.
Can I see the graph?
Okay.
KJ's just making the graph on his calculator. I expect it to wobble, get bigger and to get smaller. Let's have a look here.
The red one.
Interesting. Guys, can you look up please? Okay. This was it, wasn't it?
Yeah.
I need to zoom out though. Oh, okay, it's not as I thought it might get bigger more and smaller more. It actually kind of looks still like a sin x, doesn't it? Although it's not quite as smooth anymore as a sin x. It's more like a staircase, isn't it? If you're studying engineering, these types of graphs are important to study because they can represent signals, like electronic signals. You have different types of wave graphs like this. I don't know if you've ever heard of these before. The one which you all know, this type of wave, that's just a sine wave. That's another one. But there is an important one in engineering that's called the sawtooth, which is like this. This wave.
I saw it like
That's a way.
Yeah, a wave just means something that repeats.
wave.
Yeah. This one is important in engineering because it could represent a clock. A clock where the signal is on, the signal is off, the signal is on, the signal is off.
0, 1.
Yeah, 0, 1, 0, 1, 0, 1, yeah.
How Y X how you Y?
Here. Yeah, you see, it's not quite like that. In real life, it will be like this. When the switch turns off, it powers down quickly. So it's not quite straight. It does bend a little bit. But in our formula, we can imagine it's straight. Yeah. So you can see, this is one of the reasons it's important to study. In fact, somebody was asking me last time about product quotient and chain rule, why it's important in engineering. And another application is in the study of waves. Yeah. You can actually use calculus, believe it or not, you can actually use calculus to write this as a formula of sin x and cos x. Which might seem quite amazing. That's something that does not look like sine or cos. You can put sine and cos together in such a way to make it exactly this shape. If you wanted to read more about it, it's called Fourier analysis. It's using sine, cos and calculus to represent waves as sine and cos functions. It's only been around for about 100 years, you know, because of electronic signals. But in fact, this is the mathematics that is used as well in making JPEG files so small. You might have noticed that JPEGs are a lot smaller than other files like BMP or something like this. The reason they're a lot smaller is because it uses a lot of calculus to shrink the size down. Again, this is stuff you would do at university. Okay, let me give you one more to try here, but a triple one. Triple, yeah.
Not quadruple.
Not quadruple, just triple. Or quadruple.
No.
Do you want quadruple? I can put something else in if you want
Same
quadruple.
mistake.
Triple? We'll stick with triple?
Double.
No, it has to be at least a triple.
Okay. Same mistake.
Live there.
Take your time, go on, try this. Yeah,
when x approaches 0,
yeah,
sin x equals tan x equals x.
correct. Yeah.
So,
too long.
Nice try, but no.
no.
The problem, you don't, okay. The problem is here.
Yeah.
You don't know here that x is small.
Oh, yes.
If you knew x was a small number, then you can do this. But you don't know that x is small.
Oh, yes, I know.
Now, okay, in this case, x was small. It was
Yeah.
0.95.
Yes.
This is why your answer is quite close. It's a good estimate. But to do this, you would need to know x is small. So what you could say, if you got your pen, you could say, if x is small, then you can say your answer is x should be about 1.
Oh,
And in fact, the true answer is 0.95.
yeah.
Well, not too bad, but the problem is here.
Okay.
Yeah.
Yes. Thank you.
Yeah.
Can I write dividend?
Oh yes.
It's sometimes you write y and
Both are. This is same. This is same.
like
Yeah. This is fine. This is fine.
yes.
And it's easy to read
Yeah.
because you know it's derivative here.
Yeah.
That's good. You can do that. Is that what you did in school? Yeah. Got an answer? Is it right? Thought you were winning a prize next week. I thought you were the smart one, no? Andrew last year. No, you actually, I'd be careful what I say because he could watch this video. What could I say about Andrew?
Oh, can you tell me about me next year?
Andrew, no, Arab, from Egypt. He, no, I wouldn't say that. He just, no, I wouldn't say that. He worked really hard, and through hard work, he got the best result.
I think
Not through natural ability. You might think that's insulting, but to me, I don't think that's insulting. I think if somebody works hard to achieve their goals, it should be recognized. I feel like if you say, oh, he did very well because he's very smart, that would be nearly insulting. But he worked very hard and he got good results, and the results were deserved, so he got the prize.
how much?
I don't know how much it is, but the value is also in having the prize on your sort of record. You know, if he wanted to apply for
He not here.
some other program.
Not here now.
No, he's in study in Ireland. He'd be here next week maybe for the prize. Okay.
Yeah, that's right. And now 19.
Yeah. Yeah.
I think time touring is
How many billion?
Huh?
time touring is more time for and
Yeah.
they're more reason. I think that is a fact. Not smart or something.
No, that is 100% a fact. Yeah. You get out what you put in.
Yeah.
And sometimes students think, oh, this person is very good, but really it just is because they've done all the work before maybe they arrived here. But sometimes students think people are just born being able to do calculus.
It is like Einstein or something.
It's like what?
It's only for like Einstein.
Oh no, he would have still had to work too, you know. He wasn't that great at maths either. He was better at physics than maths.
Aren't they similar?
Huh?
Aren't they similar?
Yeah, but at university level, like, maths is really abstract, intense maths, you know. Like, at this level, they're the same. But when you go higher, it separates. So, you know, the maths at the high level, really difficult. And sometimes you think, how is this maths related to physics? It doesn't look like it is, but it actually is. It's just, it's so complicated. Because the maths at this level, you can kind of see how it's related to physics. Because, for example, you know integration calculates area, and you know that area represents distance on the velocity time graph. So you can easily see the representation, but you can't at the advanced level.
Why?
No, you can't see it naturally. Somebody has to show you that is used for that. You can't look at it and go, oh, that would be useful to use here, you know, in physics. Now this is at the sort of quantum, you know, computing sort of advanced level. Do we have an answer here?
No.
Yeah. I think we're getting all the hang of the product, quotient and chain rule. So what do I have on the bottom here? Log x squared. Okay, let's try the top now. The bottom times derivative of the top, and what do I need on the top now? The product rule. So first I need derivative of cos. Yeah, and then plus the derivative of the e sine x, which is e sine x cos x, minus the top, my goodness,
Yeah.
times derivative of the bottom. And that's it then.
You can put cos x together.
And you can put, and so on, yeah. And you could take out the e sine x as well, but we'll leave it at that then. So, like I said, in the exam, they will give you a question that requires two of these rules. So you could have something that requires the product rule twice, or product and quotient, or product and chain, or maybe even something like this that needs the product, quotient and chain. If you do get a question that requires all three, I think you would get maybe 4 or probably 5 marks. Because what they usually do is, for example, here, I could give you 1 mark for the quotient, 1 mark for the product, 1 mark for the chain, and then 1 mark for getting all 3 correct and no mistakes. So you would get 4 out of 4 for this. That would be how you might mark it.
One more mark for the patient.
Yeah, well, what they sometimes could do is they could say, find dy dx when x is, say, x is 2 or something. So to finish, what would I have to do if it was like that? Yeah, I'd have to put the 2 in at the end. And then that could make it a 5 mark question then. Yeah. So, product, quotient and chain, I think we have a good handle on it. The chain rule exercise worksheet also contains questions like this that require the product and quotient.
Is this an exam question?
This would be a hard exam question because usually it requires 2 rules and this one requires 3. But it's not really much harder to do 3 instead of 2.
Yeah.
It's the same. It's probably better if they give you 3 because you get more marks, but it's not for much extra work.
Okay.
I think so. Yeah.
At the middle of the whole stack.
Yeah.
Inside the whole stack. That is whole stack carried, right?
Yeah. Yeah. Okay. Continue. Yeah. Now, I'll let you try some of these questions for a few minutes. You can practice product quotient check. Yeah, we can try them for a few minutes. I think what we'll do is, because you don't have class at 4, we'll just continue working and finish a little early, probably be best. Yeah?
Yeah.
But I just want to give you 5 minutes or so to practice a couple of these by yourself. Well, okay, you can work together, but in other words, I want you to pick out some questions to do, and to do them now and later. Okay? Yes, because I'll print it out next week. I gave you the password. Remember?
I got the password.
Did you?